Okay. So today we're going to kind of finish up our look at evaluating trigonometry, okay, sine, cosine, and tangent. Tomorrow we're going to get into graphing trigonometric functions, okay, graphing them in the coordinate plane. They're kind of interesting, different graphs. If you don't remember any of them, I think in Algebra 2 you guys maybe touched on it a little bit or something, maybe not though. But anyway, so we'll get into graphs, and then we're going to have a quiz Friday on graphing trigonometry. Okay, so it's time trig quizzes through Thursday, and then Friday will be a normal quiz on graphing trig functions and stuff. Okay, so keep that in mind too. And then our test in this unit will be Thursday of next week. So let's get into what we're going to do today, like I said. All right, so I don't really have like an eloquent way of saying what we're doing today, so we'll just do something like, we'll call this given a trig ratio, find the other trig ratios. So it's going to kind of we're going to hinge on the idea that we're going to be given a piece of information here and then use that to help us find what the other trig ratios must be based on that piece of information. Okay, so for example, let's start with something that's maybe a little familiar from our unit circle. Sine of an unknown angle theta is equal to 1/2. Okay? So we're given this, and we want to find then cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. Now, one of these we can find without very much thinking at all, right? Which one of these is pretty easy to come up with real quick? Okay, so cosine potentially here. I was thinking more of the reciprocal. What is the reciprocal of sine? Cosecant. And so then cosecant of that same angle theta should be what? What should this be? 2. Yeah, 2 over 1 or 2. I'm just going to say 2 there. Okay. But then Joshua, you said that cosine isn't that hard to do either, right? Why? What do you think cosine of theta is going to be? Root 3 over 2. That is right. Okay. Okay. How did you know that was going to be the case? Okay. So good point. So you brought up two good things here. So let's just pause right there. So first of all, right, we recognize sine of theta, and we see it's 1/2. If we go to our unit circle, or if you think about our unit circle, or if you pull out your unit circle and look at it, right, there are a couple places where sine of theta equals 1/2. What's one of the angles where sine of that angle theta is equal to 1/2? Sine of what? 30 degrees or pi over 6. But there's another one. Where else does sine of theta equal 1/2 besides 30 degrees or pi over 6? 5 pi over 6, okay, or 150 degrees, right? And so, right, we want to be a little bit careful here, but for our purposes right here, we're not really given enough information to know, well, should we use, I mean, is our theta in the first quadrant? Is theta in the second quadrant? We don't know, so we'll assume first quadrant for right now. Later, it will matter what quadrant that we're in, but for right now, we're not really told any information about that, so we'll just assume it's all in the first quadrant. So everything's going to be what? Positive, right, since we're in the first quadrant. So we're going to have positive root 3 over 2, because at that same angle, right, at pi over 6, okay, we were able to figure this one out. Sine of pi over 6 gives us 1/2, and so therefore cosine of pi over 6 we know is going to give us root 3 over 2, and tangent of pi over 6 gives us, how can we find tangent here? What can we do now? So, okay, we could do a ratio, right? We know that tangent is sine over cosine, don't we? So we can put 1/2 over the square root of 3 over 2, which again, if I rewrite that, that's 1/2 times the reciprocal here of this, 2 over root 3 the 2's cancel, and so we're left with 1 over the square root of 3, or if we rationalize, root 3 over 3. Okay, so one of those two. Okay, one of those two. All right. So again, all this information we're building off of the fact that we were just told sine of theta equals 1/2, and from that we're able to come up with all of the other trig ratios. Okay, and assuming we're in the first quadrant. All right, what's secant of theta going to be? 2 over the square root of 3. It's the reciprocal of cosine, right? So 2 over the square root of 3, or again, if you rationalize, 2 root 3 over 3. Okay. And then what will cotangent be? Just square root of 3 over 1, or just square root of 3? Okay. Well, so the reciprocal of this would be 3 over root 3, but we could also reciprocate that, and so it's root 3.
So either one you could say?
Either one. Mm-hmm. So obviously it's easier, it's better to choose the 1 over root 3 because that is a nicer reciprocal, I would say. Yeah. Right? And so there it is, right? Without too much work.
Cosecant and secant and cotangent are like the reciprocals of sine, cosine, and tangent. Like, what do they represent? Like, where do they show up other than just being the reciprocal?
So right. No, good question. Like, why do we bother learning them? I guess, or something like that. But you're okay with why we learned sine, cosine, and tangent, I guess?
Yeah. Like, is there any place for them other than just being the reciprocal?
So the secant, the idea of a secant, you've seen that word before in geometry, if you remember. Okay, a secant line. A secant line has a it intersects. That's like what you call. It's not very special. It's when the circle is intersected by 2 points, and you'll see the word secant show up in calculus if you decide to take that. That is that's like we use a secant line, which is just the line that intersects a function at 2 points, to then approximate and eventually construct a tangent line kind of thing. Now, that doesn't really answer your question, though, the actual idea of secant and trigonometry and stuff like that. I don't really have a good answer for that. Like, I can say, for example, that, I don't know if you guys knew this or not, but like the reason why we have sine and then cosine, the co stands for complement of sine, right? Which is when we see that relationship there, the sine of an angle is equal to the cosine of the angle's complement, right? So if you take the sine of 30, it's equal to the cosine of 60, so on and so forth. That's why we call it cosine. It's because it's complement of sine. That's what I can give you there. I feel like I have looked this up in the past, and there are like explanations for it, but it's kind of like beyond what we need to concern ourselves with, I guess, in a sense. Like, for example, sine comes from the Latin root sinus, S-I-N-U-S, which means cavity. And again, it has to do with like somehow, I'm not sure. There's something that has to do with that. Or bay, I want to say, B-A-Y. So anyway, I'm not sure. And tangent does kind of have this relationship to the idea of like a tangent line intersecting at one point and stuff like that. But again, that's more than we need to worry about. So, but I understand what you're saying. I've looked at some in the past too, and I don't think I ever really came up with like a nice, succinct answer. They were kind of like over complicated and explainy, and I was like, this doesn't really answer this. But it's something we were asked. It's something that's on the that we're asked to talk about. It shows up in calculus too. So I guess they just kind of complete each other. Sine, cosine, tangent, and then the reciprocals. So, all right. Yeah. Sorry, I can't give you a better answer than that. Okay. So I can look that up though and see if I can find a better answer. Let's go on though here and let's try a different one. So we'll say tangent of theta is equal to 3. Okay. Now, is there a place on our unit circle where the tangent of theta is going to equal 3?
No.
And this is a bit of a harder question to answer, right? Because tangent's like tricky because you have to think about sine divided by cosine, but it turns out no, right? There will not be a place on our unit circle, at least that we know of, right? Like it's none of the known angles. It's going to be some other angle. So we can't use our unit circle in this case to help us find, sine, cosine, cotangent, cosecant or secant. So we can't go to our unit circle here because this is not a known ratio on the unit circle. Well, now what, right? Yep, Reese?
Can't you just assume, because we know that there's a spot where tan is 1,
Mm-hmm.
so that's just 3 times 1, so can we take every ratio that's at there, so like sine we know to be root 2 over 2, let's make it like 3 root 2 over 2?
I see what you're saying.
Because it's like 3 times it,
Where 3 is 1.
or does this not work like that? I don't know.
Well, let's do it the way that I'm going to talk about, and then we'll see how it looks. We'll see how your method compares there. I think, let's see here.
Wouldn't sine have to be 1?
But then I feel like my answer would be dumb in the end, because then when you took sine over cosine, it would be 1 again, and that wouldn't work.
The problem with, so I think here's the issue is, the problem with what you're, the problem with that is that, so like you're saying just figure out where tangent theta equals 1, for example, pi over 4. You're saying multiply the
Because
other
it wouldn't
ratios
work.
by 3.
Yeah, I realize now it wouldn't work.
Yeah, I don't think it would work that way.
3 over 2 and then for both, and then when you tried to find sine with that, tan with that, it would be 1.
Yeah, I don't think it's going to quite work. Yeah, it won't quite work. But what we can do here, okay, is we're going to go back to where you first learned, okay, in geometry about trig ratios and what they do, right? What it does, right? A trig ratio takes an angle in what kind of shape? A right triangle, right? And relates it to a ratio of 2 sides of that right triangle. So let's construct this right triangle based off the information that we've got here. Okay? We know we're going to have some angle theta in that right triangle. I'll go ahead and put it right there. It doesn't matter which of the acute angles you put it in, but I'm going to put it there. Okay? And then tangent of that angle theta has got to result in 3. Well, tangent relates what 2 sides in a right triangle? Opposite and adjacent, right? So opposite theta, what could we maybe say is the side length here? We could say 3, right? And if we say then this opposite side is 3, what does that mean the adjacent side has to be? It's got to be a 1, right? To make then the ratio 3 over 1. Did we have to say 3 here? Nope. We could have said 6, could have said 9, could have said 12. I mean, for easier numbers, you really could have said any number here, as long as then this adjacent leg, when you put them in a ratio of opposite over adjacent, it simplifies to 3. So as long as this ratio simplifies to 3, you're okay with that triangle. All right? Well, great. We've got some of the pieces in our triangle there, so now let's just go ahead and find sine. Sine takes that angle theta and relates it to a ratio of what 2 sides? Opposite, right, over the, we don't have it. Pythagorean theorem. We know 2 missing sides. So 1 squared plus 3 squared equals c squared. So that's going to be, let's see here, 9 plus 1 is 10. So c is the square root of 10. So sine of this particular angle theta will equal 3 over the square root of 10. Or if you rationalize, 3 root 10 over 10. Okay, if you like. Question, yes, Adam?
For this, why couldn't you just say, like, since tan of theta equals 3,
Mhm.
and couldn't you just say that since tan equals sine over cosine, couldn't you say it would have to be like 3 over 1 or 6 over 2 or something like that? Or are we just missing information where we can't say that?
Okay, so I think, let me just see if I see what you're saying. So you're saying since tangent theta is equal to 3, or let's just say 3 over 1 maybe, then you're saying, okay, well then sine of theta over cosine of theta, sine would have to be 3, cosine of theta would have to be like 1, like that.
Yeah.
The problem with that is because there's, like really an infinite number of different combinations that would give us that 3 over 1. So saying sine of theta would have to equal 3, it could be 6 or 9 or whatever kind of thing. Same thing with the 1 then kind of thing. So, but now here in this triangle, we're okay with it being general, like 6 or 2 or 9 and 3 or 12 and 4 here. Because, hello, thank you. How'd the chocolate pie turn out?
It's kind of bland.
Oh,
I was
no.
team banana the whole time, but nobody shared any of their bananas. So.
No one shared their banana.
Rough day.
Oh, oh man, Emma, that's no good. Okay, anyway, so the idea though with that is if it's okay to have 6 and 2 and stuff like that is because then this would also be in the same proportion, right? If we doubled this, then this would be, if this was like 6 and 2, this would be 2 root 10 when we did our calculation here. And so all those sides would be similar and stuff, and it would create the same ratios still. So, other questions before we move on here and get the rest of it? Okay, good stuff. Good thinking here, guys. So cosine of theta then, cosine of theta is adjacent to our hypotenuse, so 1 over root 10, or rationalized root 10 over 10. Okay? And then cotangent's easy peasy. What's that going to be? 1 over 3, right? Just the reciprocal. Cosecant is the reciprocal of sine, so it'll be root 10 over 3. And then secant is the reciprocal of cosine, so it's just going to be the square root of 10. Like so. Okay? So, if you can use the unit circle, do it. If you can't, then just draw a picture. Draw a picture. Okay. I'll do one more here, and then I'm going to have you guys try one. All right, one more here, and this one we won't go. We won't go too crazy. We'll say cosine of theta is equal to x over 3. Find sine theta and tangent of theta. Yeah, go ahead there, Kenny. Okay, so unit circle, probably not going to be super helpful here because we have x, right? And none of our unit circle ratios have x in them, right? And so we can't really use unit circle, so that means we need to do what? Draw a picture, right? Draw a triangle here. So we'll draw a right triangle. Okay. Place your theta at any of the acute angles. I'm just going to put it right here. Okay. So then cosine is the ratio of what two sides? Adjacent over hypotenuse. So x, adjacent leg, over 3, like that. And if we want to find sine of theta, that's equal to opposite. Ooh, we don't know it, but how can we find it? Pythagorean theorem. So be careful how you set this up. We're going to do x squared for the leg. I'm going to call this leg b. So b squared then for that leg squared. And then the hypotenuse is going to be 3 squared or 9. What variable am I solving for here in this Pythagorean theorem setup? B, right. Be careful. There's 2 variables here. We're going to get b by itself. So b is equal to the square root of 9 minus x squared. That's our side length. That's the best we can do. Okay. And so then, the sine of theta will equal the square root of 9 minus x squared over 3, right? Opposite over hypotenuse. And the tangent of theta will be the opposite, square root of 9 minus x squared over x in this particular case. Okay? Questions on any of that? All right, so you guys try this one then. The cotangent of theta is equal to x plus 2 all over 7. Find sine of theta, cosine of theta, tangent of theta.
X plus 2 we have to keep together the whole time if we do Pythagorean theorem, right?
Right. but I did, because I think, you know, in case you see this as factors.
Can you help me?
I hope so.
So I'm trying to do this easy way, but I don't think I
Easy
can.
way.
So I put this to get tangent, right?
Yes.
And then isn't tangent sine over cosine?
Yes, with a but. That's not the only way to get tangent to be 7 over x over 2. Right? I mean, yes, that would work, but that's not going to be necessarily the case here.
Wait, how do you get x?
Right? For example, sine of theta could be 7 over 2, and cosine theta could be 2 over x plus 2, and then when you divide them, the 2's will cancel, and you'll be left with
I don't like this.
a drop
You just didn't want to solve it.
That's right, that's right.
That's an algebra question.
Algebra question.
So, so when I set it up like this, when there's c squared, if I take the square root, do they both cancel out or no?
So, whenever I have questions like this, and when I think about these when I was a student, I would try and come up with like an equivalent kind of like problem that allows me to then see whether it works or not. So for example, something like this, right? And it's similar, right? Both are perfect squares. You're adding them up. So what you want to do is what? You want to make this be, right? And so that would be 8. Right?
Yeah,
However,
they're not for.
what's 9 plus 25? Oh, shoot. Let me do it easier. There you go. Makes it easier. 9 and 16 makes that and that. Okay, but 9 plus 16 is also, which is equal to,
Yeah.
so
It doesn't work.
it does not. Correct.
So then would I just write that as take the square root of the whole thing?
Yep. Square root of a sum is not equal to the sum of the square root. If it was a product, no problem. If this was 9 times 16, then it would be 3 times 4. But since it's addition or subtraction, can't break it up. Because you think about it's the same reason why when you have x plus 2 quantity squared, you can't just square the individual terms here. What is a square root but the square root of a sum, but raising it to the 1/2 power, so you can't distribute it just like you can't distribute it here. Same principle. Same principle. Yep.
So, when you put it into the theorem, can you just take the square root right away? Nope, you can't. God dang it. Because I put on 9 plus x squared plus 9.
Oh, square root of the quantity x squared.
Yeah, because I had x squared plus 2 squared plus 7 squared equals b.
It should be x plus 2 quantity squared plus 7 squared equals c squared.
So can't you just get rid of the square?
Oh, whoops.
No, because it's a sum. It's a sum.
You can't just take the square root.
No.
right
If
away.
you take the square root of, wouldn't it just cancel?
It's like,
Think about this. The square root of 9 plus 16, if you were able to break the square root up, that would make it then this 3 plus 4, right? 3 plus 4 is 7. But if you add these two numbers together, you get 25. Square root of 25 is 5.
So it's 7, it's the square root of 7 plus x squared plus 2. The square root of that, all that junk?
Yes.
On our answer, do you carefully simplify it down to like a polynomial?
No. No, if you left it as the quantity x, if you left it as, hold on a second, if you left it as the square root of, if you left it as that, that's fine. Yeah.
Do we need to write 45 or do we need 7 squared?
You can leave it as 7 squared if you want.
And oh.
Answer it. Okay, moving on. Any other questions on this? Okay, you cannot break up a sum underneath a square root. Okay? It is the exact same thing as trying to break up a sum of something square, right? If you have x plus 2 quantity squared, you know that is not the same thing as x squared plus 2 squared, right? We know that. We have to FOIL it, right? Same principle. Because is not a square root the same thing as raising something to the 1/2 power, just like we're raising here something to the 2 power, okay? So please, 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 don't break up a square root, okay? The square root of a sum is not equal to the sum of the square root. But if it was a product, if this was 9 times 16, then you absolutely could break it up. Okay, one more question here for us, and then I'll get you guys started on your assignment. Find the trig ratio given the terminal side of theta goes through -3, 4. Find the trig ratio. Find the trig ratios. Sorry, I want all of them. Given the terminal side of theta goes through -3, 4. What does it mean? Good question.
What does terminal mean?
Terminal.
It's like an airport.
That's right. So we're going to start and stop our
I
journey.
find the ratios of the airport.
Yes. Trig ratios of the airport, not just ratios. And it's the airport's at -3, 4. Or they go through -3, 4.
I don't think they do it like that. I think it's usually like 4B or 6B.
This is a math airport.
Do you think in latitude and longitude that there's like an exact like point that is like -3? Like
I feel like at -3, 4 would probably be in an ocean. Because isn't
You mean like on
like where the equator meets the prime meridian, isn't that like just south and west of Africa?
Yeah.
It's like in the water, I think is where it happens. So. Anywho. Okay. No, we're gonna do this together. Yeah, we're gonna do that right now. So this problem's a little bit different, right? Yeah, Grace has got this one for us, right? Grace Kelly, dance it away. Okay, so anyway, all right. So anyway, -3, 4. So we got a coordinate, so we got to go to the coordinate plane, right? And let's kind of like roughly sketch where -3, 4 is. So -3, we're going to go left 3, and we're going to go up 4. Okay, something like that. Okay. And I'll go ahead and draw a line that goes through that point, -3, 4. Okay? Right, and so angle theta's terminal side, that means where the angle of theta ends, right, where angle theta ends. So let me do it this way. So in other words, theta goes like this. It's like, that's theta, right? Okay, from the x-axis around to it goes through -3 over 4. That's the terminal side, the ending side there of the angle. Okay, now. This is a little weird, though, because what kind of angle is angle theta? Obtuse. And we normally solve trig. We are dealing with what kind of triangles? Right. Acute right. Well, specifically right triangles, right? Can you have an obtuse angle in a right triangle? No. Okay, it's impossible, at least in Euclidean geometry, right? So what do? Okay, we're going to use reference angles here, reference angles. In the same way that we did in the unit circle. Remember in the unit circle, right, we did all the angles here in the first quadrant, like pi over 6, pi over 4, pi over 3, and then we kind of used some transformations, and I talked about reference angles. We're going to do the same thing here. Okay, same thing. So the reference angle is always made with the x-axis and the angle right here. So this is going to be the theta we're actually going to consider right there. And we'll just drop a vertical line down there. Okay, what are the dimensions of this triangle? What's the height of this triangle going to be? 4. What's the length right here of this leg?
3.
So since it's a length, we'll say 3, but you could label it as -3 if you wanted to, but I'm going to label it as 3 since we're talking about a length. Okay, and that would make the hypotenuse 5, right? This is a nice Pythagorean triple. 3, 4, 5. Okay? 3, 4, 5. Okay. So we can create a right triangle here, yes. So let's now take the sine, cosine, and tangent of this angle theta, and then we'll also go ahead and do the reciprocal trig functions too. So cosecant, secant, cotangent.
This is gonna be like tomorrow.
Say again?
This thing's not gonna be on our quiz, right?
Tomorrow's quiz will be on what we said earlier. It's on the board over there. Okay, no. But it could show up on Friday's quiz. Could show up on next Thursday's test.
So it's basically the same thing.
Yes, quiz this Friday. What's that?
It's basically the same thing we took today, more numbers and more like ratios.
It's like it's a little twist from what we did earlier in the earlier rounds. Yep. Okay, so what's the sine of theta going to be? 4/5. What's the cosine of theta going to be? 3/5. What's the tangent of theta going to be? 4/3. And then we'll just do the reciprocals, right? So cosecant is the reciprocal of, it's the reciprocal of sine, which in this case, yes, will be 5/4 is the answer. So reciprocal of secant of theta is cosine, so 5/3. And the reciprocal of cotangent will be the reciprocal of, it'll be tangent, so 3/4. Now, remember when we were doing angles, when I showed you the method yesterday, when we were doing angles on the unit circle, right, we used reference angles, didn't we? I said, okay, if you get like, for example, 5 pi over 6, the reference angle for that is pi over 6. Okay, so for example, if I say, what is the sine of 5 pi over 6? I was like, evaluate sine of just pi over 6, and then go back and adjust the sine depending on what quadrant you're in, right? Okay, so 5 pi over 6 is in the second quadrant, right? And so then sine is positive in the second quadrant, so you keep it positive. Well, same idea applies here. We're using reference angles, but we need to take into account the fact that the actual angle places us in quadrant 2, okay? Are all trig ratios positive in quadrant 2? No, okay, right? That only occurs in quadrant 1. So in quadrant 2, what trig ratios are going to be negative? Cosine, tangent, and then of course their reciprocals, secant and cotangent as well, because if you reciprocate a negative number, it's still negative. All right, and so there's your final answers right there. Okay, because we were in quadrant 2. Those had to be negative. Okay, questions on any of that? All right, if there are no questions then, I would like you to get started on your assignment here. It is in the book. I'll put the assignment on the board, and I'll also post it to Google Classroom as well. Okay. All right, here we go. Page 316, numbers 13, 15, yes, 25, 27, 69, 70, and 73. Okay, 316, 13, 15, 25, 27, 69, 70, 73. Yeah, go ahead. So let's please get started